From the sands of the Arabian desert rises the tallest man-made building on Earth. This is a city in the sky with almost a kilometer tall. The Burj Khalifa is the pinnacle of skyscraper engineering and owes its success to seven key inventions. To explain that, I have lined up seven landmarks buildings which are historic giants of the skyscraper world. Inside each one has a major technological innovation that allowed engineers to go even higher. The first breakthrough happened in the 19th century with the Equitable Building that was only 43 meters tall. The builders of Equitable Life in New York realized that before buildings could be taller, they had to find a way to make people climb higher. But the stairs were not the solution anymore. The solution was obviously the elevator, but there was a problem. Nothing could stop it if the rope broke. But then a mechanic solved this problem by creating a simple device that could stop the elevator in case of an emergency. The safety elevator allowed the skyscrapers to break the barrier, and suddenly buildings were big businesses. But as they reached more and more meters, traditional materials were not strong enough. To make the leap to the 85-meter Fuller building, the skyscraper had to be reinvented. Previously, a building in Chicago sank half a meter due to the extreme weight of stone. But there was also a problem. The skyscraper had to be triangular because of the narrow space. The answer made the building out of steel columns and beams lagged together into a steel skeleton. As steel is much stronger, the skeleton could be thin and light. Then the structure could simply be covered by thin walls like curtains. Now the challenge for the engineers is to stop the baking desert sun from turning the glass tower into a giant oven. To beat this new enemy, skyscrapers would have to get cooler. So, in 1947, when the United Nations designed their new headquarters in New York, they wanted to cover the entire building with glass. The glass wall would allow a lot of light into the building, but also solar radiation. As the sealed glass couldn't let the hot air escape, things would rapidly get uncomfortable. So an American engineer cracked the cooling problem. With this machine, the hot air is sucked into a chamber where water particles absorb heat so that the air is cooler. Air conditioning allowed people to work comfortably, and housing more workers leads to greater profits. The only problem was that bigger skyscrapers took much longer to build, so engineers have to invent a much faster way to build. To reach the 471 meters of the World Trade Center, engineers had to invent a new much faster way of building skyscrapers. As the construction started, the clock would start ticking, and every day the building was unfinished, it would have cost a lot. So they had to find out a way to reduce time to the minimum. The solution was to prefabricate sections of the towers and assemble them like a jigsaw puzzle. This, the sections were constructed off-site and shipped them to the construction site when they needed. Prefabricated technology allowed giant skyscrapers to grow faster, which made them even more profitable and desirable. But as skyscrapers went taller, they encountered a new enemy. To build the Sears Tower in the windy city, Chicago, engineers had to turn the skyscraper inside out. This is because using a traditional skeleton would have caused problems. The taller the tower skeleton is, the more it bends, making the upper floors to sway, and then the people could get dizzy. The solution was to shift the steel framework from the outside of the building to the outside. I mean this. This is called exoskeleton, which made it very hard the wind to bend the building. So, as the Burj Khalifa is twice as tall as the city's tower, its shape plays also an important role. Each section of the tower is designed to disrupt the power of the vortices. With mobility, gravity, heat, and wind conquered, the skyscrapers faced its next big challenge. In Asia, where booming economies wanted to show their wealth, super tall skyscrapers become the object of desire. But Asia is located where a phenomenon is very common: earthquakes. To make the Taipei 101 possible, skyscrapers have to take another leap. The architects faced a problem. The building sits near the Pacific Ring of Fire, the most seismically active area on Earth. For that, the design made the building rigid where it had to be, but flexible where it could afford to be. The Burj Khalifa can withstand earthquakes of up to 6 on the Richter scale because it has a massive reinforced concrete skeleton. Today, a final technological lab keeps the occupants of the world's biggest skyscraper safe. The more you build, the more people have to walk farther to get to safety. The Burj Khalifa has built-in fire protection as concrete is naturally fire resistant. But how do people get out in an emergency? The answer: they won't go out. The building contains special rooms which are built from layers of reinforced concrete. The walls of these rooms withstand the heat of fire for 2 hours, and each room has a special supply of air. To sum up, standing on the marvels of engineering, the Burj Khalifa is the ultimate skyscraper until someone builds a bigger one. Thanks for watching.